Good morning. This is Dr. Madhusudana Reddy, PVR with Kavali. This video session for Thought BTech second sem EEE students. Subject is Design of Photovoltaic Systems, Unit 1, which contains PV cells. Already I covered 6 video sessions for one. This is the 7th video session. This video session containing, already I started in cells in series, but I want to know about the characteristics, IV characteristics regarding these cells in series. There are two types of cells in series, identical cells and non-identical cells. If you connect the identical cells, how it behaves. If you are connected non-identical cells, how it behaves. So this behavior we need. First of all, see here cells in series. So this is the way how we are connecting the cells in series with the alpha equivalent back. So let me go through this. I want to explain about this IV characteristics. So first of all, you see here, this is about both cells having the same characteristics, ideal same characteristics. They're having the identical characteristics. Identical cells, identical PV cells are connected in series or connected in series. Okay. Here, identical PV cells are connected. So when you are having the identical PV cells, then the same cells having the short circuit current same ISC1 and ISC2. Similarly, here also, this is about VOC, both cells having the both cells. Both cells. Both cells we are having the same. Here also same, both cells. One and two. Have the same character. Okay, understood? So this is about the cell 1 and cell 2 having the short circuit characteristics, ISC1 and ISC2. And R is equal to 0. R is equal to infinity. So this is about the individual. Then we combine together what's happened here, current will not change. Okay, in case of the series connection, current will not change. ISC is equal to ISC1 is equal to ISC2, but voltages will be same. So this is about combined cell voltage. Combined cell voltage. Combined cell voltage. So this is about VOC1. When you add these two, see here, this is a double for this. Yes or no? This is off and this is off. We combine together. VOC is equal to VOC1 plus VOC2. This is about the representation of IV characteristics when identical PV cells are connected. Similar way, if you increase another, for example, 3 cells, then what's happening here? So like this, you see here. You see here. Decrease like this. Okay, yes or no? So R will come back here. We'll go to this. So this is about maybe VOC. three cells. If three cells. Okay, understood? If VOC, if three cells, total voltage. Okay. So like this in board as this, we are having three cells when you are connected in this series, identical characteristics. So we are having this equivalent. Okay. Now I'll continue with if non-identical cells are connected, then what's happening? Okay, that I'll explain. Next, I'll continue. So I think you understood that much. This is about the IV carrier. So let us see how the two series cells work and what will be the resultant IV carrier of these two cells. So here X and Y axis. X axis is the voltage. Y axis is the current. Okay. You'll see here VOC1 and IOC1 representing PV cell for 1, VOC2, ISC2, not sorry for this. ISC2 represent for. Okay. So here this VOC2 already I explained all these things how you are adding. Next will come back. I want to explain about the load line. So what is the load line? What is the load line? So we remember what is the load line mean? So this is about the cell. This is about the cell. So this is about the cell. For this we are connecting the load. This is about the load. This load is a variable R0. If R0 varies, this line is also varies. So what is the load line? The change of voltage with respect to the current is called as the load line. Here, so for example, here we are having the load line. If the resistance decreases, okay, yes or no? If the resistance decreases, then this load line here. If the resistance increases, okay, the load line, okay, the load line here. For example, the resistance increases, the load line here. So what's happened here is the operating point changes. When you change this resistance, its operating point changes. Whenever this operating point changes, like this, you towards to this is about the tangent. What is this operating point? The operating point is nothing but at which the point crosses this IV characteristics as a tangent. Okay, so it's called as a load line. Okay. See here, load line on IV character of the PV cell. Consider the PV cell R0. You keep it as a variable. So R0 is varying from 0 to infinity. If it is 0, which is if it is 0, the load line is like this. Is always in parallel with I axis, also called as a Y axis. If it is infinity, if it is R0 is infinity, then it's on X axis, are also called as a voltage axis. Okay. So this is about R0 is varied from 0 to infinity. 0 means short circuiting the terminal R0, S R0. 0 means short circuiting. Infinity means open circuiting the terminal. See here, this is about the VOC, ISC. Okay. So now let us plot the IV characteristic. The x-axis is VT, the terminal voltage. Y-axis is the current through the external load. So this would be X and Y-axis. On this axis, let us place an arbitrary IV curve. So let us have a curve like this. Okay. So let me now draw a line, a straight line like this. We'll get into, I consider the slope of this line. Vertical concept would be delta I and horizontal projection would be. So this is the delta I and this is the delta V and delta I. So this horizontal represented as a delta V, this vertical represented as a delta I. Okay. So So here you'll see that vertical intercept would be I, horizontal intercept would be delta V. So therefore, the ratio of delta I by delta V is slope. That slope indicated as 1 by R naught. That indicated as a low line. External output impedance as seen between these two terminals. So this line, any line you draw like this from the origin or not line is called a low line. So if you draw a arbitrary load line, the point of intersection is the operating point of the load R naught. So for this load representing 1 by R naught, operating point, and I showed you. So this is the operating point. And this is the operating point for this. This is the operating point for this ISC. This is the operating point for this is the VOC. The other all some operating points. Okay. So let me go for it here. These things already explained. So this is about when R naught infinity, VOC. When R naught is 0, when R naught is 0, ISC. R naught is 0, ISC. Okay, all the things already explained. So with this,